great. There's still a keynote afterwards, so I think that will be a great one. Um, I hope you had a great time. Also, thanks to the organizers, obviously, because they did an amazing job, as far as I heard. This is me, Frederik van Brabant. I'm a keyboard for hire. It's a funny way to say I am a software consultant. You can follow me on the socials. I have maybe Frederik on maybe basically all of my socials. And frederikvanbrabant.com, which is my blog, which I don't update at all, so I have no idea why it's still up there. Also, I must maybe interlude this for a bit. This talk is from 2019. There's this thing that happened in the meantime. I don't know if you noticed. Not a lot of conference talks during those days. So it's in itself a tiny bit of legacy. So, oof, you didn't expect that one. What are these things? Audience participation is also part of this talk as the first one. These are indeed watches. We have to the left, your left, the Omega Speedmaster. To the right, we have an Apple Watch. I'm going to speak at my notes because the prices update all the time. The fancy watch is from Omega. It's a very renowned brand maker. They sponsor two famous people. In general, they sponsor James Bond, which is kind of a cool guy. And the other one is a bit less known. It's Neil Armstrong. He landed on the moon with that thing on his watch. The thing goes for 8,000 euros currently. That's a lot of money. The other one, an Apple Watch. What does an Apple Watch cost? And not the golden one, which they launched with. That was 10,000. But the Apple Watch is about a few hundred quid. I shouldn't use quid because we aren't in England. It's 330 euros. Let me feature up. I promise this is going somewhere. Let me feature up some things about that cool watch. It loses time by about 3 seconds a day. It's not very accurate. You don't have to wind it. Doesn't take any batteries. It has kinetic energy with your watch. It's pretty cool. The other one can read your email, does your taxes, and makes you look very spiffy with a turtleneck on. Why am I doing this? Stupid comparison. I'm not a salesperson from Omega yet. These two watches serve totally different ends to a mean. This thing is developed in the 60s, less of the 60s, especially for the space race, and still clicks today. This one, for the keen viewers here, this is the first Apple Watch. Does anyone still have the first Apple Watch? I don't know, is it still supported even? Is that a problem? I don't know. It shouldn't be. This one is one that fits a lot of cases, goes very hard, very fast. This one is more of a slow burner. It still keeps its value. If you get your hands on a watch from the 60s from Omega, it's worth a few quid more than the 8,000 euros you're paying today. The one to the left, I don't know, you might have to pay it to do the recycling costs. Anyone familiar with this company? No? No one? It's a small startup in Silicon Valley. They used to be called Facebook. These days they're very meta. Why? Oh, okay. Why did I bring this one up? In 2007, Facebook had a bit of a oopsie. Instead of rendering their usual Farmville, they rendered the source code, the backend source code of their PHP application. Whoopsie daisy. Oop. Okay, we lost the screen. And we're back. Crisis averted. So they displayed their backend, their index.php. Now, as I figure, most of you are Drupal developers. Your PHP index file is not that big and not that important. Turns out that Facebook, in that time, had 4 files. One of them was index.php, was a few thousand lines. Full, oh, god damn it. Is this on my end? Probably is, right? I can, I can keep an eye on it, maybe. Oh, so good. Okay, so as you can imagine, bit of an embarrassing situation for Facebook. But what was displayed was a few thousand lines of PHP code. You can still find it online. I didn't link it because I'm not an idiot. Well, discussable. But you can still find it. It's something strange happening here. I'm just going to mirror my my screen. That's maybe. Sorry about. Oh, okay. Um, oh, damn it. Ooh, spoilers. Oh, god damn it. Going to quickly take this away. Ah. Nope. So, okay, this should work, right? Okay, oopsie daisy, Facebook, blah, blah, blah. Not great. You can find the code online. What's the point of this one? Facebook had PHP software, which is cool, right? In 2009, which I don't have my speaker notes anymore, so you have to trust me on that one. So the thing about Facebook in 2009 is they ran PHP software. Facebook from 2009 is a total different beast from the meta thingy we have these days. They still use, well, not exactly PHP. They wrote their own interpreter called Hack, but they still use PHP. They still emerged. They iterated on their existing code regarding that. So what's the main take about these first two examples we made here? Well, the thing is, your PHP code has inherent code value. It's a rough diamond. Legacy code bases all have the main big ideas in them. They are you just have like all the business value is there, all the pitfalls are there. Bloom bloom. Okay, yeah, okay. Sometimes we're going to fall away, I guess. So all the business value is there. Everything is there for you to like iterate upon. The thing with legacy code is it's proven its value before. Otherwise, you wouldn't be supporting it still, right? So everything is there. We just have to polish the rough diamonds. And that's why we're going to dive a bit into PHP code and why legacy is still a great thing. So how do you get started with legacy code? Well, obviously you're not going to get started because the main definition of legacy code is that you're already doing it. But how are we going to clean it up a bit? We're going to dive into three main parts. First one is the mentality, which I think is very important for you to have a clear understanding on how you should approach these things. Second off is the code mentality. This is more the fluffy part. Then we go to the code mentality, how we can actually like think about our code in a different way. Last part is the more technical part. It's going to be amazing. So the mentality. First things first, don't rewrite. Following the steps of Facebook there, it's very, very easy to see a code base, very ugly code base, and just think to yourself, okay, going to throw this away, and then we're going to write it again. Now, put yourself in the shoes of your company. You have a big company, you have an application that's making a lot of money for you, and your code team goes to you and says, oh, we're going to throw it away. Yeah, we're not going to throw it away. Also, what's your next case? Okay, we're going to throw it away and build it again. You're just going to put your current application on pause for like, what, 2 years? That's not going to happen. No. We're going to split our code teams in two. One of the teams is going to support the old legacy application, and the other is going to build the cool new thing. Okay? Which part are you going to do? I'm going to do the cool thing, yeah, obviously. Who's going to do the old thing? Nobody's going to do the old thing. Okay, we can switch around a bit. Yeah, but then what's the point? Like, there's no point. It's very bad for your business. So a more intelligent approach would be to iterate on your code and maybe try and phase out new IDs and phase out older IDs. Okay, now the clicker is gone. Okay, we're back. A quote, famous quote. Who knows the quote? No, the thing about this quote is every time I ask who knows the quote, nobody knows the quote. I thought it was a famous quote. Move fast and break things. Unless you are breaking stuff, you aren't moving fast enough. There goes the screen. Ah, right. Must be it. Uh, so the guy who said that never worked on legacy code. The guy who actually said that was the same guy who invented that startup in Silicon Valley at the start of the talk, Zucker something. So move fast and break things. If you aren't breaking stuff, you're not moving fast enough. Now the thing is, a lot of startups a few years ago in the early 2000s, yes, I'm that old, they embrace this entire thing, like disrupt the market, move fast, and they also applied it to code. We need to move fast and make new code and blah blah blah. And then we ended up with a lot of legacy. Don't move fast and break things, especially if you have legacy applications. Slow down. What's the thing? You have a code base that's generating a lot of money for you. It's a rough diamond. Slow down and like take care of it. Make like ensure yourself that your code will be still your code tomorrow. Act like it's open source, which is a bit, I don't know, a bit floaty. What do I mean with that? If you were to commit your current code base to open source, what will be the first things you have to do? First of all, you might be a bit ashamed of the code, especially if it's legacy code, just dump it in the open source thing. Also, I'm not saying put it open source, obviously. Act like it's open source. Your second step would be write a ton of information, a lot of documentation, the pitfalls. How do we install this? How do we take care of that? How are we going to do code commits? All these things, which is strange. That's super normal in the open source world, but in multinationals and enterprise software with millions of euros that generate profit like insane, we don't do that. We don't write a ton of documentation in our applications. That's insane. Why don't we do that? Especially if you have legacy code bases. Automate and analyze everything. We're going to dive a bit deeper in this in the more technical part, but you have a big open source, you have a big legacy application. It's probably a huge thing. Nobody can keep that in their minds. It's very important to take a step back, dump all the automation on it, like code analyzing, like code climate, Cask. There's a ton of tools out there. Also, GitHub supports with their tooling a lot of automation to scan your code and let the software and the machine learning and whatever all the fancy words and buzzwords are there, let them analyze the code and see your biggest pitfalls, see your biggest threats, your biggest security issues. Move from there. Start and make a plan from there. Don't just think, all right, that big class we have, it's an insane big class. We always have a ton of issues with it. Let's just rewrite it. No, like take a step back. Don't move fast and break things. Move slow and fix things. Take a step back. Go in a meeting. Discuss what's actually the issue. Do it with metric data, and then start to promote a battle plan. Yeah, this is I adapted it to the Drupal crowd, which is you. I added modules. Normally, it's like we have like a huge PHP stuff kind of thing, and we want to move it towards a framework. Like a lot of legacy code out there is just frameworkless. It's just like the old CTO invented a framework, and now we're using it still. It's horrible. The CTO left 20 years ago. It's the same with modules. If you're thinking like, I can fix this very easily with a different module, but your current code base doesn't support that module, well, stop thinking about trying to work towards that module. Maybe take the owl and just take a step back and, I don't know, maybe we should use this module, but maybe we can write our own module that fits our use cases. You have legacy code, your code is very mutated already. Don't try to force it into like a box or anything. Just try to analyze your current code base and move forwards from that one. Bloop. Oof. Yeah, I still had a joke in there. So working with legacy code base is stepping outside of your code base. What's the idea here about what Jamie Oliver said? Maybe is that you have these typical mindsets which you want to apply, but don't do your current thinking to your code base. Analyze your code base and see how your code base is, and apply your own thinking. Apply the code base thinking to your own ideas. So try to like assimilate yourself a bit with the code base and try to see where it's at, not where you want it to be, but where it's realistically going to be at. Okay, so the code mindset. We did the first part. Now let's go to the next part. So the code mindset itself. Flicker, flicker. Okay. There's a lot of stuff here that's going to look a lot familiar to you. It should be. All of these things are generally known as clean code. So keep methods and classes small. If you're refactoring a big class, try to refactor it to smaller classes and methods. The entire solid thing, solid there's a lot of controversy the last years about how applicable it still is, but personally, for me, I think there's still a lot of value in solid. So if you refactor stuff, try to make your classes very small. Uncle Bob, another maybe controversial person these days, once said that a class should be around 100 lines and 2 indentations deep maximally. I think that's a bit hardcore maybe. I would love to see his code. I don't think I've ever seen it before. It's probably out there. But I don't think it's a bad rule to have like very small classes and keep them portable. Why? Easy to read, easy to communicate about, easy to test. Actually, only like more file size, more files and more disk space. But let's be honest, that's not really an issue. The same regards, keep PRs and commits small. If you do commits, they're called what I like to do are atomic commits or smaller commits. I like to tell a story with my pull requesting commits. If you have 2 files and you're moving stuff between or you're refactoring, first step is, okay, let's look at the code, maybe do some style cleanup, that's a commit. Okay, let's move this part of the code over to the next file, that's a commit. Let's refactor this small part of code, that's a commit, that's a commit, that's a commit. Okay, let's move over the second one, that's a commit. Okay, that's a PR. And then you have a beautiful story which you can follow for the person who's going to review it. That's the next one. That person can go over the commits and see the story evolving. Again, we're doing legacy code bases here. Nobody in the world knows what your software is doing at this point. So it's really handy to have like a story. Every time a big change comes, you have a story that says, okay, we did this, 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 this. It's very easy to communicate about it. The code reviews. As I said, code reviews are, for me, one of the most essential things in software development. Who here does code reviewing? That's a big, oh, wow, okay, cool. A lot of people, that's great. Yeah, code reviews. For this crowd, it's very obvious. Cool. Code reviewing is very important. Sit together, talk about the code. There's also the ego part a bit. It's always a bit, just remember, you are not your code. You can have a bad day, you can have a good day. The other person can have a bad day, can have a good day. Be polite about it. There's a lot of talks out there, how to do good code reviews and how to give good feedback. I think that's very important to you, especially as you're going to refactor legacy software. Coming together as a team and having each other's back, and don't let the egos interfere a bit. That's really important because you're not doing a small task here. Yeah. Pair programming. So we did code reviewing. Who here does pair programming? Okay, 2 people are pair programming together. Okay, with 3. Okay, so normally I ask who does mob programming, and then obviously in the room it's also one weirdo. So, oh, of course. They never do. So pair probing for the uninitiated. What's the idea? You have two people together, sitting together at the same computer. One is a driver, one is a navigator. I think that's the right term. The driver drives, which is code, and the other one navigates and thinks out loud. Now, obviously, the driver is not just typing what the other person is saying. No, they have a discussion about what they're doing. For refactoring code, it's a gold mine. Now, from a managerial standpoint, this looks like two people doing one job. No. It's a very common thing that managers react that way, but in reality, it's totally not about that. It's coming together. Two people are fixing issues at this point. Two people are looking at the same problem, discussing possible pitfalls that they shouldn't, that might pop up in the future in code reviewing. Code reviewing goes a lot slower because it's an async process. Two people sitting together at a computer, a lot faster because it's a synchronous process. In this case, it's faster async than async. So two people working together. I'm going to be honest with you. It's also a bit. If you're an extroverted person, this is a walk in the park. If you're a very introverted person, this can be a bit. The entire day sitting next to someone discussing the code, it can be very exhausting. Just like try and see how your people are. Code pair programming isn't for everyone. Mob programming is with more than two people, 5 people, 10 people. For very complex problems or coding, I've known companies that only do pair programming and mob programming. If you're not familiar with the entire idea, it sounds insane. If you're familiar with the entire problem, it also sounds a bit insane. But okay. So about this, so legacy code gives you great insight into why some good practices exist. Good practices like solid code, don't repeat yourself, which is also a bit controversial. All these very old school things we've been saying since the 60s are extremely important to implement in your code reviewing and your legacy code bases. Small classes, small PRs, don't nest ifs, do early returns, all those classic things, extremely important in legacy code bases. So, okay, down to business. Getting started with legacy code itself. So you have a blob of legacy code in front of you. What are the steps I can take for myself to like dive in a bit? First of all, get your builds, get deploys under control. Very important. You have a code base there. You want to be able to fail. This is extremely important. You want to dive into the code, try something, see if it works or not. If it doesn't work, go back, try again. If you don't have Git in your application, your entire thing, you might think, of course, who doesn't have Git? I've worked with a lot of companies, a lot of legacy code. This isn't obvious. First of all, install Git. Make sure you can go back and forward with your code base. Don't have index in parentheses 2 in your new folder 3. That kind of stuff, don't put it on Dropbox. No Git, we're grown-ups now. Or you're not. If you're not a grown-up, that's also okay. Cool for you for being here. And your deploys. If you want to deploy stuff to master, or maybe to production as well, stuff breaks because it's legacy code, get it back as soon as possible. Green-blue deploys, pipelines, all those things might sound a bit daunting at this point, but it's very important. Fail fast, fail quick, and most important, get back to your starting position. So get that under control. This might or might not be an immense task. Second of all, use a debugging tool. We have Xdebug. We had some other tools out there. Freek did a talk about one of his on Monday. I totally forgot. He's a good friend of mine. But don't tell him. So there's a debugging tool out there. Use it. Use all the tools out there you can muster. Get insights in your code base. If you have a nested if from 4 ifs deep indentation, it's really hard to keep your mind up to the task of what's that value again and how did we get here? use tools designed for that. Don't just echo and die stuff. There's a lot of complexity here. You might not uh, dive deep enough and get enough information from those tools. Use dedicated tools for that stuff. Use a full-on IDE. This is really important. I know VS Code is really cool. I know Sublime is really cool. I know Coda used to be really cool. I know Notepad++ is a thing. There's a lot of things there. So what I would personally recommend, I'm not sponsored, obviously, should be, use PHP Storm. PHP Storm is extremely powerful. It might be a bit expensive, but looking at like the time gains in your entire thing, it's peanuts. So ask your employer to buy you PHP Storm. So yeah, whatever your excuse is, it's invalid. Use a decent IDE, except if you use Vim. If you use Vim, you do you. You're probably way too deep in that stuff. You use Vim. I don't care. I don't know. I don't even know how you work. They always seem to be one step ahead of everyone, or Emacs. But I heard Vim was better than Emacs. Okay, so this is the longest thing in your entire refactoring part. Write end-to-end tests. I'm not talking about feature tests. I'm not talking about shadow testing, mutation testing. Almost no. Just start with end-to-end tests. That's obviously if you don't have any tests. If you have tests, please validate your test before you rely on your tests. There's mutation testing, which is really, really interesting to look into. If you don't have tests, which probably your legacy application, there's a big chance, from my experience, that you might not have testing in place. So start with end-to-end tests. This is also a beautiful moment to actually get some managers in the same room as you and say, okay, this big application that brings us a ton of money and we all are getting rich from it. What does it do? And then you have managers that say, okay, if we get an order from here, then a mail gets sent out there, and then this happens, and it turns out it totally doesn't do that. So it's really also a bit of a wake-up call to have people in the same room and talk what actually your application does, what it should do, what is the critical parts, what are the least critical parts, and write end-to-end tests for all of them. It's a lot of work. It's very stressful. It's not a fun job, but it's one of the most important parts in this entire journey. Have a backup. Have like a safety net so you can fall back. If you change something, it should be catched by the tests. And then we start working outside in. First of all, start with the critical paths, and then write back in. What do I mean with that? I made some handy diagrams. This is you. No, this is actually the code base. It's currently not a happy code base because it's a bit old, which is, you can still be obviously very happy when you're old. Writing back in. So we wrote those amazing end-to-end tests. We have a ton of them, more than 4. And we want to write our shiny new code around it. This is the write outside in. So we have the old base at the center, and we want to write our new shiny code around it. As you might see here, there's a bit of a problem. The screen going away. Okay, so how do we connect our shiny new code that we're going to write around our old code with our new code? One of the possibilities here, there are a ton of possibilities here. Another one to look into is a strangler design pattern. But this one is what I call, well, we'll dive into it a bit. So this is a bit of legacy code. Is that readable? Because there's a light right on it. So I'll walk you through it. So at the top, we have the PHP opening files. Then we have a million things, because we're doing legacy code base. And then we have, this is a bit of an old school Symfony code. What we're going to do here is we're going to make a connection to our MySQL instance. with our password and everything in it, because obviously we're going to check if there's a connection error. If not, we die, because that's what legacy code does. Then we write some very cool SQL inline. We do the query, we close the thing, and we continue with the files we got from the database. Now that I'm looking at it, it should go to a variable, because now we don't do anything with the file. So this is maybe some very, very obvious legacy code. How do we refactor this? So first thing what I like to do is what I call a transformation layer. What we do is we make, next to that class, we make a new class. That new class doesn't do a lot of stuff. First of all, we get a container. We get the main container for our application. From that container, we get a repository class. From dependency injection, we can do dependency injection, which we'll see later because it's a static function. And then we do the add food stuff. This might seem a bit out there at this point. We just make a small translation layer. Then in that translation layer, we have our new shiny code. Here we can use a connection with a query builder, which we inject doing dependency injection. And here we just use doctrine to do the, we apply to the database. Now this is the shiny code we like. Now, how do we connect the shiny code we like with the old code? That's where this, so this is the old code again. And now we can just take all these lines and replace them with the fruit translation layer, which is already connected to the container. And here we just apply the things we want to do. What are the next steps now? We go through those top million things and down those other million things down, and we replace them all with translation layers. And translation layer. And in the end, you just have this file, which is only translation layers, and then you can just drop it and directly go from wherever you want to go to the new code, and you continue doing that entire route. This is one approach. There are different approaches. This is one I've used in the past that proven to be very, very helpful and still gives a lot of insights. There are some other upsides here. Now, obviously, you're going to write all the tests, like the unit tests, mutation tests, shadow testing, feature testing, to the new code, not to the old code, but to the new code, which is, as maybe you've used TDD to write a new code, which should be very testable and very portable. Okay, this is also a thing that also comes up. We should maybe try to do a refactor of our old code base into microservices. This is a scary one. Do we want to have microservices? Always comes up. It used to come up more in what's upside down? It used to come up more in like older, like a few years ago, where microservices were still like the new fresh big thing. The thing about microservices is you need to have a DevOps team to have your microservices. You can do it yourself, but you're wrangling a legacy code base at the same time while implementing microservices. I don't know, it's a bit of a and also it's really complicated to do deployments and all those kind of stuff. So in general, I would say don't go to microservices, but if you wanted to go to microservices, if you look back to this translation layer, like this part, I have a laser, forgot, I have a laser. This part, which is referencing the new code, could perfectly reference a microservice or an external service or whatever. And that way you can actually easily transform your old legacy code base to microservices if you're insane and you wanted to do that. So that's an extra upside you get here, is the decoupling of all of your code to smaller, easier deployable functions and methods. Okay, cool. We've done, if you look at this stuff, we've done a lot of stuff, but what about code structure and project structure? DDD, domain-driven design, I don't know if people are very familiar with it. It's a bit of a complicated thing. It's also, a bit misknown with developers because a lot of developers look at it and think in very technical things. But DDD is more of a global thing, like talking about code and making codes more of a universal thing instead of a developer thing. But still, DDD has some technical things we could implement in our application as well. So, order per domain, not per action. Wow, DDD words. What do I mean with this? This might be, you're going to have to use a bit of your imagination and transform it to a Drupal module because I'm not the biggest Drupal developer in the world. So this might be a typical look for a typical old school PHP application. We have an app container, we have a folder with all our controllers, models, validators, transformers, all those kind of things. One way we could refactor this is to make it per domain. So here we have DHCP stuff, we still keep the controls in one place, but then we make a user folder and a post namespace. And in that post namespace, we have a validators namespace. That way, it's easier to talk about. Like, where's my user stuff? Oh, it's all in the user namespace. Okay, cool. Now, if we have different teams, we can, if we have like a huge application, we have, for example, 50, 60 developers, we can have a users team, and we can have a posts team. Also, we can, if you, again, wanted to, extract all these different namespaces to microservices. It's an upside. I don't know if it's an upside. I like using it that way. I think it's easier to talk about with people. Also, your errors are very, very clear where everything is. Gives you direct insight in where everything is. Also, you're not talking about user create anymore. You're just talking about create, which is nicer, I think. So that's that thing. So one step further, value objects. Who knows what value objects are? Okay, cool. That's valuable information. That was a joke. So user repository. So for example, this is a typical user repository. Here we set teacups. We set teacups, the amount, and the ID. What ID? I don't know. In this case, it's a user ID. So we add teacups to a user. How many, the amount, and then the user. Okay, cool. So this is the user controller. Here we do the repository. Then we're going to update. This is your repository, and we set the teacups. What was first, the teacups or the user ID? Anyone? What? The amount first, and then the user ID? How sure are you? I don't know, because if you're not sure, you're now going to update a different user with a different amount of teacups. Okay, we're doing teacups here, but we're not really doing technically very, very deep stuff, but this is like bugs waiting to happen here. I know your IDE will tell you, and you can just click through and you can see, but do you want that? That sounds a bit, I don't know, a bit weird, no? Why would we have so much trust in stuff like that? Okay, what we could do is create something called value objects. So here we make a small class, user ID, and we make it the ID itself. Oof. Okay. Here we have the user ID. This is a small example of a value object. We have the construction. The constructor, it just takes the ID. It does some validation, which is really nice. Then it sets the ID, and then you can just get the value or get extra function. In this case, it's get as a UUID, but you could also, is it even, is it uneven? Now we're talking about IDs, it's a bit weird, but for example, a color could also be a value object. And then you can say, get it back as hex value, get it back as LUT value, get it back as user-readable names, something like that. Also, it's extremely, it should be immutable. So every time immutable means that you can't change it. So it's the idea if you want to have a new value object of a user ID, you can create a new value object. You don't update this one. The big upside from that is that you can always pass it through and it will always be the same and you can trust that it's always going to be the same. An ID can be all over the place of what the idea even from. This one you can track very easily. Okay, cool. I guess you're now a legacy code developer, right? So we dive into it. Obviously not. Well, maybe you are, but still not from this talk, I guess. Legacy code is something very very strange. It can take like all the different forms. It's really complicated stuff. So I hope I could have given you some insights. The big insights, I'm afraid you have to learn yourself, because legacy code is something very mysterious and it always takes every shape possible. I gave you some ammunition there. You can apply them, but you're going to have to learn a bit yourself. Um, you're going to see some funky things, which is cool, because your interpretation of what code might do might not still be the actual thing that the code does. So if you see a function that is insanely complicated and you can just replace it by 2 lines of code, and you think, why the hell was it ever this complicated? Well, a bit of empathy there. If you look back at the developer that wrote that original code, he's probably not an idiot. There were a lot more cases there. There's a lot more information going on that you're currently not aware of. So take it with a grain of salt. Always, if you replace a big hunk of code with a small hunk of code, maybe check that it still does the same thing. Okay, cool. And if you see funky things, it's a beautiful thing to learn. If you learn stuff like that, you can write blog posts about it. You can coach junior developers, media developers, senior developers. There's a lot to see here. It's quite the adventure. I'm making it sound very exciting. It probably isn't. So yeah, it's going to be great. Always, I just did that. Want to learn more about legacy code bases? There's Modernizing Legacy Applications in PHP by PM Jones. I'm actually listing all the very controversial people of PHP in my talks. It's amazing. Then there's Working Effectively with Legacy Code from Michael Feathers. It's a huge book. It's an insanely big book. It's very nice to read. No, it's not very nice to read. There's a lot of information there, but it's very complicated. It's a very good source. There's also, if you want to dive deeper into like good practices and see how modules or PHP packages are written nicely, there's also the League of Extraordinary Packages, which has a lot of very clean code, which I personally really like to use in projects. I think we kind of lost the screen here. That's okay. We're at the end anyway. So dive into that stuff, and well, I'm now updating my my clicker, but whatever. So thank you, and if there are any questions or whatever, I'm more than willing to take them. If we have time for those, we do. Okay, great. Thank you. All right, yeah, the thingy. Hop. Oh, good catch.
So I know this is like what the question of what legacy code actually is of course a very subjective one. I'm just curious how, like, if someone were to ask you, is this legacy code? What would you use to answer that question personally? What would you look for?
I'm so glad that you asked this question, because I think it was in my notes, which I didn't have.
Ah.
So this gives me a bit more time to actually talk about it. So legacy code is, there are a lot of definitions, as you said, about what's legacy code. The most common one that I hear is bad code is legacy code. In that case, I write a lot of legacy code. That said, what I personally like, the actual definition of legacy code is code that the different generation of developers in front of you wrote. Legacy code can be amazingly good code. There are probably some 60s code out there that's beautiful. It's still legacy code. Now, what I used to, there's a lot of connection between spaghetti code and badly written code with legacy code. This talk was actually more towards the more spaghetti code, fast iterative code, than it was more about like old school code. I should do a talk about old school code. It's kind of cool, yeah? I hope that wasn't a very confusing answer to your question.
No, it was. It was. I think it's part of how I would have answered it.
Oh,
Yeah.
great.
Yeah.
Anyone else?
Hold on.
So I just wanted to ask, is there ever did you ever do a project where the code was so like unsalvageable that you said just let it run for as long as it runs, and then after we just rebuild the whole thing?
Yes, I'm currently working on a big enterprise application, which runs on an. It's written in RPG. Now, personally, I never heard of RPG, and it runs on AS400. Personally, I was not that familiar with AS400. It's those big IBM servers. If you say IBM servers, you might think, this might be a bit old school. That thing is pretty old school. It predates COBOL. So it's pretty old school. Like a lot of banks, a lot of big installations still run stuff on that, which is the case of, well, it brings a lot of money there. It's very complicated to remove. And we're kind of now in the process of like switching it, first of all, moving it to the cloud, which is okay. And then like switching it out with modern stuff. Very, very, very dangerous stuff because RPG, the language it's written in, doesn't support a lot of stuff. It doesn't support a lot of testing. It doesn't support Git, for example, which is scary. So it's really complicated. The case for that is, yeah, let it run for as long as possible, and then try to build safety nets around it. Because it's been running for 30 years, it's not going to crap out next year. But well, you're pushing your luck at some point, right? And also, you need to be more portable, have quicker features, stuff. So you run against those limits eventually, but in the meantime, well, yeah, see what you can do, obviously, and try not to get in that situation.
Okay, yeah, thank you.
Nobody? Okay, great. Thank you so much for coming over, and again, thanks to the organization for everything, and I hope you have a great closing keynote. Thank you.